So number one, it says, give me an equation that is continuous but not differentiable at the location of x equals to 3. So Lauren, did you come up with one?
Y equals the absolute value of x, right?
Okay, so let me write your answers down. Again. Y equals absolute value of x minus 3. Is Lauren right? Yeah. Okay, you can do a lot of stuff with the a value. I can move up and down. Wouldn't that be okay? Okay, but that's the minimum. Okay, I can put 100 in the front, add 1,000 in the back. Okay. Next, give me an equation that has a cusp at the location of x equals to -1. Noelle, did you come up with one? Maybe, that's okay. Let me verify. Tell me.
Y equals the third root of x squared plus 1.
Third root of x squared plus 1. Okay. What do you think? Would that be okay? It's not okay. How do I know if there will be a cusp at x equals to -1? Because remember, on the test, everyone's going to have a different answer. What would I do to prove it? I have to do left and right derivatives, right? So I'm going to quickly do it really quick. This is really, it looks like the whole thing, it's x squared plus 1 raised to the 1/3 power. Would that be okay to write? Okay. So let's see, left-hand derivative. I want to prove it really quickly. The limit as h approaches 0 from the left, if I'm looking for at x equals to -1, would you agree that -1 plus h minus f of -1 all over h? So when I plug in -1, by the way, what's f of -1? -1 squared is what? 1. 1 plus 1 is 2. So third root of 2. Is that correct for f of -1? So f of -1 equals third root of 2. Okay. So here we go. I don't have a quicker way. I just had to prove it to come out. Both, if the infinities are the same, I'm sorry, if the infinities come out to be different, then that would be true. Would you guys agree? Yeah. All right. Let's plug it in slowly. Here we go. Third root, or actually, let's use exponents then. -1 plus h, that has to be square, plus 1 on the back. All of that is raised to the third power. That's just f of -1 plus h. Would you guys agree with that piece? Yes, no, maybe? And then minus f of -1. We said f of -1 was third root of 2, which is really 2 to the 1/3, if that's how I want to think of it as well. Yes or no? All over h, okay? Well, I need to FOIL out -1 plus h. -1 plus h is 1 minus 2h plus h squared. All of it, I'm sorry, and then plus a 1 at the end. I have to be very careful with my basic math. All of it minus 2 to the 1/3. Is that still okay? Yeah? Now what? The 1's canceling? Yeah? Oh no, that makes it a 2. Oops, I got too excited. Dang it. That makes it a 2. Okay, I got too excited for that. So now, going. So this is 2 minus 2h plus h squared, right? Whew. To the 1/3? Minus 2 to the 1/3? All over h? I would have to rationalize the top. Can you guys see that? I can't distribute the power because these are not multiplication. This is really the third root of all of that and third root of all of that. There isn't like a nice way of doing that. Someone punch out a calculator for me. Graph that out. Let me know what it looks like. Actually, just graph. Do me a favor. Graph Noelle's. This is her made-up equation, okay? It may work, it may not work. Who knows? Can you graph that for me? I want to know what's happening. I feel like... So graph Noelle's a highlighted equation. This is her made-up one.
Right? I looked at this is the example, and I did a horizontal change.
It may work, it may not work. Who knows? Okay. x squared plus 1 all in the raised to the caret of 1 divided by 3. Did it work?
Yeah.
I'm checking it right now. Oh, that doesn't look like it. I have like a V-ish looking shape. Do you guys have that?
Yeah.
Yeah, so does that constitute a cut at, actually it's a 0. Would you guys agree? Like there's a V, the vertex is at 0, 0, 1? Yeah, so right now that, based on my graph, does that qualify? Based on the graph, would that qualify? No. Okay, so that one, yeah, but at least we checked it out. Okay. Anyone give me one that will work? I'll verify it for you. We don't know.
I did
X plus 1 to the 4th fifth equals y. Do you guys agree that? Would this work?
Yeah.
Yes, this will work. If you graph it out, there's a difference. Okay, so this is x plus 1 in quantity. X plus 1 equals quantity raised to the power of 4 divided by 5. Okay. Yeah, so this is definitely moved to the, can you see that it did move left by -1 when you graphed it out? Versus no L, we tested out. I'm so glad because the other one would raise it up, right? And this one's moving left. Yes, that would also. Can I have x plus 1 to the 2nd over 5? Would that be okay as well? How about 6th fifth? How about 2nd divided by 3? Any one of those would be, yep.
So the first equation, like instead of having
In quantity. Yes, that's the difference. Okay. You guys hear what Sammy said? On Noelle's question, if I were to do the plus 1 in the quantity, would that be okay? Sure, that would totally be okay. This is good. All right. Then last one. Anybody want me to verify the last one for you? To see if it's okay. Give an equation of a function that is neither continuous nor differentiable at x equals to 0. Yeah.
F of x and then piecewise.
Give me piecewise.
3 and then x is greater than 0 and then -3 x is less than equal to 0.
Okay, so it says not continuous or differentiable. So if I were to sketch it out, okay, so you're saying at anything greater than 0, you have a hole going that way. Anything less than 0, you have a closed dot going that way. Do you guys agree Daniel's right? Yeah. That's one of them. Anyone has something else?
Would the absolute value of x over x work?
Absolute value, so your equation is absolute value of x over x. Okay. Do you think that will work? Yes or no? Anything greater than 0 will always be what? 1. Is that okay? Anything negative will always be what? -1. Is that still okay? All right. Perfect. Derivative on the calculator. Raise your hand if you already know how to do the derivative on your calculator. Okay. Okay, so this is like an easy one for us then. Okay. Here we go. Method number 1. This is going to be a graphing method. Graphing. And again, guys, your calculator may be slightly different from mine. So we're going to work together to figure out how you can use your calculator. So let me give you an equation. Y, they said use your calculator, find the numerical derivative of y equals x to the 3rd at x equals to 2. Okay, and only use your calculator. And then it says verify using your form or definition for a derivative. So do me a favor, go to y1, punch in x to the 3rd. Now everyone do that. y1, punch in, let's clear out whatever you had before. We tested out a bunch of equations just now. Now clear it out. Okay. Then once you have y equals x to the 3rd and y1, I want you to hit second and then find calc. If I'm going too fast, please let me know. Which one of these buttons do you think I'm going to use? 6, you're right. Can you see this thing, dy dx? Okay. Okay. Did it give you this? Guess what this is? This is a graph of the original or the derivative? This is the original. Did you guys agree with that? Okay. Now, remember, how do we get, I want to find the derivative when x equals to 2. How do I do that? Uh-huh.
Select y, yes,
Okay, good. Once you selected dy dx, guess what? How did we find the value before? Anybody remember? How did we find the value before? Anybody got it? How do we find the value before? Press 2. And then did it give you an answer? What's your answer? 12. Those are, okay. I'm going to go back and do it again, so wait, I'm not losing anybody. So we went and did, right? We did y1, plug in the value. Is that okay? And we second calc. And we went to dy dx, and then we plug in 2, just 2. And then we get, okay. Remember, don't be confused. On your screen, there's a lot of things going on. And you see, once you hit dy dx and you plug in 2, it says x equals 2. And then it says y equals 8. And then there's like a small value, like right above those things. It says dy dx, and it's like 12.00, right? There's a bunch of stuff. So make sure we know the derivative. Anybody has a different calculator and duplicate that. Make sure. There's like 3 things on your screen. Do you guys agree? So we've hit dy dx, and then we just hit anybody else on this method before I go into the second method. This is just one of the ways. You okay? Next, method number 2. We're gonna, okay. We are going to graph out f prime. Graphing f prime. Okay. So we already have, guys, we already have y1 in there. So don't do anything with that, just leave it there. Can you go to, move your cursor to y2. Go down to y2. And then can you find math for me? Find a button math. I don't want to, so go down to y2, find math. And then I want you to go all the way to, can you see number 8? Number 8 says, and derive. Okay, like that. And maybe, am I losing anyone yet? I want to go, right down the steps. Yes? So, go all the way down. Again, I don't want to lose anyone, so make sure you guys write down the steps as well. Go to and derive. Are we okay so far? Okay, go to, and then I want hit enter, obviously. Now, the bunch of screens, a bunch of blank spaces will pop up. Okay. On your Y2, can you see there's a bunch of blank spaces? New calculator and old calculator, they're 2 different kinds. Okay. So let me tell you about the difference between the 2. Okay. Some of you have this. Here's this. And then I'm just writing down the blank boxes, okay? If this is you, and then here's a blank equals a blank. Raise your hand if this is you. Okay. Anybody? Okay, so all of you? You have the old one. Okay, so an old one, okay? Old one or new one, it doesn't really matter. I think an old one has, okay. Okay, so old one and old new one, it doesn't really matter. Guess we are taking the derivative with respect to what? X. So this X goes right there. Okay, so this X goes right there. So that's always what variable we are taking the derivative with respect to. Now this parentheses, since we already have y1 in there, if it's an easy equation, you can just punch it in like ours, like x to the third. Now if it's like some crazy equation, then you can go and put y1 in there. Anybody know how to recall y1 back? Okay. Anybody? Vars is right, okay? But if it's an easy equation, you can just go and retype it. There isn't a difference. Does that make sense what I'm saying? Okay. Again, this one right here, if it's an easy equation, you can retype it. But if it's like some crazy thing and you don't want to retype it, you can hit recall. Vars, right? Go to function, and then y1. Then, this box is permanently there. Guess what goes here? Yeah, put an X there, because I just want to graph it out right now. So this gets an X. Okay. X, and then for me, I'm going to recall it for y, for vars. So y vars, go to function, y1, and then this is X. Okay. Hit graph. Yes, that blank space is permanently there. Oh, yours going to be placed? Mine just get permanently there. No, I just want to graph it out. I don't want to find the values yet. Yeah. So guys, the reason I'm using X is I just want to graph out the derivative function together. Okay. So, and then old calculator, we'll talk about you guys. So you should have a red or whatever color, 2 different colors. Can you guys see on your screen? Guys, I don't want you to plug in a value yet. I just want you to graph 2 functions together right now. Okay. So, again, looks like this is permanently blank, but it looks like it fills itself in. Am I correct? Yeah. So it looks like it fills itself in on some so that's fills itself in. Okay. Anybody have both right now? Okay. It's going to take a while because to calculate derivatives is pretty difficult. Now, the older calculator, you will see. And derive. Okay. So for this one, same thing. So keep showing that. Okay.
Using the left and right hand.
Older calculators, you're going to have to fill out 3 different spots. Okay. So older calculators, when you hit Y2, this is the older, it will say n derived. Then I think Y1, recall Y1, X, comma, X. This is for the older calculator. Okay. So again, you're still going to fill out 3 different spots, like this one, that one, that one. Okay. So this is just graphing both at the same time. Are we okay with just graphing both functions together? Okay. Now, sometimes I'm going to give you some crazy functions that, you know what I mean, that you can't find the value right away. You can graph the derivative function and then go. If you look at it, you have the derivative and the normal together. But from here, hit second calc. And can you see in second calc is a value number? Number 1 is value. You can find any derivative from here. So if you were to say, okay, I want to find calc, hit x equals to 2, okay, and enter, it's going to give you 8, but look where the dot is. It's on the blue curve, or whatever curve is. You want to move it to where it is on the derivative curve. So move it up or down. Okay, so make sure the cursor is on the right function. Okay. So go to second calc value and make sure the cursor is on the right function. If it's on the original, it's going to give you 8. But if you hit the arrow up and down, it will jump to the derivative function. It will give you your value. Okay, yes, so hit, go, all bars. And then go down, I'm sorry, with y bars. Function. And enter, put comma. X, comma. Write that all down your paper. That will give you your derivative curve. And it's very slow to graph derivative, okay? Okay, any questions on graphing both out and finding your derivative that way? And remember, using the arrow up and down will help you jump from the regular to the derivative function. Does that make sense? All right, next one. Method 3, non-graphing. So the first two are both graphing. Okay, I want you to go to math and then go out down to number 8. What's number 8, guys? What's number 8? Okay, so I'm sorry, go clear everything out, just like a normal screen. This is non-graphing. So clear out, blank screen. Clear out your screen. Hit math. Go down to number 8. What's number 8 again? And derive, right? Okay. You are trying to evaluate a function called x to the third. So that's your function. The second, hit, can you find me a button that says comma? This is for older calculator, because I'm going to take care of old calculator first and the new one. Earlier we did the reverse. Old calculator, you put in x to the third. We're taking the derivative with respect to what? X. So that's, you got my old calculator? This is how you do it. We want to find the derivative when x equals to what? 2. All right. Now when you do that, hit enter. What did he give you? New calculator, same thing. Math, number 8 still, so that doesn't change, but your visual looks a little bit like this. Yes or no? Quantity, still put in x to the third. Then this is x equals to 2. So all of that's in. So this is your x spot. This fills in us. Okay. This is what you fill in. So new calculator. Okay. New calculator, old calculator, doesn't really matter. Do we get the same answer? Yes. So we did multiple ways, graphing and non-graphing. We did a way of just graphing the original. We did a way of graphing the derivative and the original, and then we did this without graphing. Sometimes one will be easier than others. Okay. New calculators, old calculator students. Are we okay? Write down the steps. Okay. So this is your notes. Okay, now practice. 1, 2, 3. One of those 3 calculator method is best for you to use. Which one do you want to use? So on number 2 it says f prime, graph f prime your calculator, and then just sketch it right there for me, okay? So once whatever is on your calculator, just give me a sketch. So practice what we just learned. Once you have an answer to number 1, talk to each other. I got this. If you don't know how to use calculator, please let me know. I don't want to walk around and help you today. If you have an old calculator and you don't know how to work it, you have a new calculator and you don't know how to work it, just sketch it. You have a new one, that's legit, yeah. So, how did we find that? Remember, we don't use x to the third anymore. We're looking for this, right? Anybody have the answer using calculator number 1 yet? What's answer number 1? 11? Okay. Yeah, and number 1 you can use any method you want. It isn't a way that I need or want you to use. You figure out a way that you want to use it. 1, 2, and 3. And then on number 3, just summarize what we just did. Just for 3 ways, we can use a calculator. Anybody need help on number 1? You got 11 there? Good. And then number 2, how do you graph out the derivative on the calculator?
I just want to move it instead of
Yes, I'm looking for that.
that's very good.
And this is where we're going to stop once you have described 3 ways. What is the graph of the derivative, which is number 2 on your note? What does the calculator show? A linear, you're right. Make sure you look at your calculator and sketch it out. Oh no, it has to intersect the y-intercept a certain way. You found the derivatives. How do you graph out? Graphing derivatives is so fun. All right, guys, we have tutorial today, so come back if you still need one-on-one support.